After the invention of computer systems, we have used it extensively for various purposes in our daily life. This is because computers can do so many things that we are not capable of doing. Computer systems can do hundreds to thousands of calculations within a matter of seconds, can work for a very long time without getting tired, and computers are also much less prone to error whilst doing a certain task unlike human beings. So we can see that computers fill up the human lackings in several ways. However, despite having all these advantages over a human being, computers also tend to find some tasks extremely difficult to achieve compared to us. Image recognition can be one prime example in this case. Our brain has been developed specifically to do image recognition tasks almost effortlessly. This is why we can naturally recognize other people, differentiate between different objects quite easily, and perceive the world around us visually. We can do these tasks so easily that we don't even need to think about how complex all these tasks really are. This complexity only becomes apparent when we try to make a computer to do all these things. Things like image recognition, differentiating between objects has always been very difficult for computer systems, and we human beings have excelled at these tasks. All this has been true before the beginning of the era of AI or artificial intelligence. Since the beginning of the era of AI, however, computer systems are getting better at understanding visual images almost every single day. In fact, computer systems are getting so good at image recognition that it is often doing almost as good as human being, or doing even better sometimes. This improvement of computer systems has only been possible thanks to the magical word called, wait for it, machine learning. Machine learning is a subset of artificial intelligence that enables machines to learn automatically through experience. This concept of machine learning is actually quite similar to the way we learn in real life. Machine learning also has a lot of application beyond image recognition, and in this lecture, we'll talk about different types of machine learning and some of its applications. There are mainly three types of way a machine can learn. Those three types are: number 1, supervised learning, number 2, unsupervised learning, and finally number 3, reinforcement learning. Let's talk about supervised learning first. Imagine you have a little kid and you want to teach the kid how to recognize cats and dogs and how to differentiate between those. You can follow the simplest approach here. You can simply show the child an image of a cat and tell the child that, "Dear child, this is a cat." Similarly, you have to also show an image of a dog and tell the child that, "Dear child, this is a dog." Here, you are showing the kids some data with their level and they are learning from it. The data are the images and the labels are the names cat and dog. Now, both cats and dogs come in various shape, size, breed. As a result, simply showing one image of a cat or a dog might not be sufficient to learn the differences very well. The more images you show the child, the more it learns the differences between cat and dog. And the more differences it learns, the better it manages to distinguish between those two species. In case of supervised learning, this is exactly how computer systems learn. It sees some level data and learns from it. The more data it sees, the better it does. Spam email detection is probably one of the most common and relevant example of supervised learning. To differentiate between spam and non-spam email, machines take a look at some emails which are already labeled as spam or non-spam and then tries to label new emails as spam or non-spam based on the learned knowledge. The more email it sees, the better it does. Spam detection system is still learning from new emails every day. Therefore, it is getting better at spam detection regularly. Secondly, let's come to unsupervised learning now. We can often distinguish between different objects without really knowing what they really are. We can mostly distinguish those based on different attributes such as their size, shape, color, and more. Let's say if someone gives you a bag full of onions along with garlic and then asks you to separate the two types, do you really need to know which ones are the onions and which ones are the garlic? The answer is not really, no. If you look at the mix of those two, you'll be able to notice clear differences. Obviously, onions and garlics come in different colors, different shapes. You can also taste them to find out the differences. You will be able to notice these attributes naturally and divide up the onions and garlics accordingly. And in this case, you would never need to know the names of those ingredients. If someone asked you what you actually divided, you would probably answer it by saying that you divided up some red looking things and some white looking things. And the differences in the colors were apparent to you when you just looked at the items. Nobody needed to tell you anything about it. Unsupervised learning for computer systems work in a similar way. In the case of unsupervised learning, computer systems look at some data and try to divide it into clusters without really knowing what those data are or what those data actually do. Google News is a very good example of unsupervised learning. If you go to news.google.com, you'll see several segments of news presented to you. Perhaps you'll see COVID-19 related news in one segment, different political news in other segments, and perhaps another segment will contain the recommended news based on your preference. Now, nobody told Google what those news are all about. The system just looked at some words in the news and tried to dynamically determine the type of news based on it. So, unsupervised learning is a process of differentiating unlabeled element into appropriate segment of clusters. Reinforcement learning is another type of machine learning, and it's a little different than supervised or unsupervised learning. Unlike supervised or unsupervised learning, reinforcement learning has less involvement of data. Rather, in this case, machines learn from trial and error process. We human beings learn a lot from trial and error process since our childhood. Imagine a baby going near a fire source. When the baby feels the extreme heat of the fire source, it takes the heat as a negative sensation. Due to this negative sensation, it learns never to go near a fire source ever again. On the other hand, if it tastes something good, such as a piece of sweet or a chocolate, it decides to eat even more chocolates in the future. In these cases, the baby is learning from the sensation it receives. When it gets a positive sensation, it decides that the task is good enough to do. On the other hand, when it gets a negative sensation, it decides not to do the task ever again. In case of machines, we refer this sensation as a reward system. We set a goal for the machine, and if the machine does something that prevents it from achieving the goal, we give it a negative reward so that the machine never tries to do it again. In contrast, if the machine does something that helps it to achieve the goal, we give it a positive reward so that the machine keeps on repeating the same thing again and again in the future. In this way, even if the machine makes a lot of mistakes at the start of its lifetime, it adjusts accordingly by seeing those mistakes thanks to the reward systems and starts doing much better later on. Let's say you want to make a coffee making robot and you want to apply reinforcement learning on it so that the robot learns to make coffee properly as fast as possible through trial and error process. Now, the goal of a coffee making robot would be to prepare coffee as fast as possible. During coffee making, if the robot makes a mistake such as, let's say, breaking the cup, the coffee making process gets delayed and the robot gets negative reward. This robot learns that breaking a cup hampers it from reaching its goal, so it should never break another cup again. On the other hand, if it manages to prepare the coffee in the shortest possible time, we give it a positive reward so that it can repeat the same process in the future. Reinforcement learning in real life is much more complicated than that actually, but in this case this is just a simplified example.